Hello everybody, it's Miss Fincham and we'll be continuing Unit 1 by covering Topic 4.2, Soil Formation and Erosion. Soil is an incredibly important topic in APES. It is going to serve as the foundation for understanding how plants grow, how water is filtered, and so many other important functions that soil plays. Our learning objective today is to describe the characteristics and formation of soil. We will be really focused on how soil forms. It is important to know that soils are formed when parent material, which is the rock underlying soil, is weathered or broken down and then transported and deposited. We also have to know that soils are categorized by different horizons or layers. We will talk about the characteristics of those layers. We also need to know that soil can be eroded by winds or water. We will also talk about how soil is degraded or what can happen to lower its ability to grow plants. Our suggested science skill for the day is to identify a research method, design, or measure to be used to conduct an experiment. We will talk about that at the end of this video. So what is soil? Before we get started here, we have to talk about what soil actually is. It is really misunderstood. A lot of the times, we call it dirt. We know that's not something we're going to do in APES though this year. We will talk about what it is and why it's important. Soil is a mix of geological and organic components. These are rock-based components and components that come from living things. Either they're alive right now or they were once living and have decayed into organic matter. First, we have sand, silt, and clay. These are the three main particles that make up soil. We will talk about those in the video for 4.3 soil composition. Then we have humus. Humus is the main organic component of soil. It is that dark, rich, black substance that kind of gives soil its characteristic color and even its smell. It is broken down organic matter like dead plants, dead leaves, animal waste, or even dead animals. Then we have nutrients in the soil. Things like ammonium phosphates and nitrates are going to be really critical for plant growth. Water and air are part of the soil. They fill the little spaces or pores in the soil. Air is important because it has oxygen that plant roots need. Of course, they need water as well. Then finally, we have living organisms, so earthworms, fungi, bacteria, and other decomposers that are going to help recycle nutrients. There are four really important roles that soil plays in ecosystems. First is that it supports plant growth. It is going to serve as an anchor for plant roots, and it's going to provide them with the water and the nutrients that they need. These are things like nitrogen, potassium, phosphorus, and magnesium. We can see this tree here has established its roots, and that is going to help hold it up. Next, we have water. Soil is a really important water filtration system. When we have runoff or rain starts to trickle or percolate through a soil, the spaces in the soil, those pore spaces, will actually trap pollutants so that clean water can pass through and recharge groundwater sources and aquifers. Then we have nutrient recycling. All of the decomposers in a soil are going to break down the dead organic matter. They're going to return those vital nutrients to the soil, so it's really critical that we have soil for the purpose of recycling nutrients that are needed for new growth. Finally, we have habitat. Soil provides a valuable habitat to organisms like earthworms, fungi, bacteria, and even moles or other animals that live underground. They all really benefit from having that habitat or space to live. Next, we will talk about weathering and erosion. They are very important and sometimes they are confused with each other. We have to be sure that we understand what the difference is between them. Weathering is just the breakdown of rocks. That can happen in three ways. It can happen by the wind or in the rain, which we call physical weathering. It can happen by chemicals, so there could be acids that are in the rain called acid precipitation that could break down a rock. Then we have biological breakdown. This is when tree roots actually grow into the cracks of the rocks and break it down in another way. Physical weathering happens when rain seeps into the cracks of rocks, and then when it freezes, it expands, and that breaks the rock, which opens further. Once we get weathering of rock, that is how we actually start soil formation. Those bits of rocks are broken down into smaller and smaller pieces, and those are the pieces that ultimately make up soil. Before that happens, we need erosion to take place as well. If weathering is the breakdown of rock, erosion is the transport of those little pieces of rock. Here we have a great diagram. We can see that as rain falls, it's going to detach or break off little bits that have been weathered. Then it is going to transport the small pieces and move them somewhere else. Deposition is the last step of erosion. We can see soil is starting to build up in layers here. So erosion is critical to soil formation as well and together. With weathering and erosion, we actually create soils. We break rocks down into smaller bits through weathering, and then the wind and the rain carry those little bits somewhere else and deposit them. Soil formation can also come from below. This is the weathering or breakdown of parent material. Parent material, sometimes called bedrock, is the rock that underlies soil. All soil has rock beneath it if you go deep enough. The weathering or breakdown of that parent material is going to produce smaller and smaller bits of rock that will eventually work their way up and will form much of the inorganic or the geological part of soil. This is going to contribute a lot of the sandstone clay and a lot of the minerals then that we also have in soil formation. So the grass and the plants that you can see up here, they're going to die eventually, and when decomposers break their bodies down, they will contribute humus to the soil. That is going to really contribute to the soil nutrient levels, and it's going to add to the depth of the soil. Then we also have the weathering and erosion that we talked about on the last slide, where erosion can break down rocks and carry the little bits of rock and deposit them into a soil, which also adds to its formation. There are also a few factors that affect the rate of soil formation. The first one is parent material. Depending on what sort of parent material you have, the soil can take on different attributes of that parent material. That is going to determine the soil pH and the nutrient content. For instance, if we have a soil that has limestone bedrock, that is going to lead to a lot of calcium in the soil, which is good for plant growth. This also helps to buffer acidic soil, so limestone can be a really beneficial parent material or bedrock to have. Then we have topography. If the slope is too steep in an area, then soil formation will really be hindered because so much soil is going to be eroded away from that area, which is going to slow down the rate of soil formation. However, if you have more level ground, especially nearby a more steep slope, that is going to lead to a lot of soil deposition, which can increase the rate of soil formation. Climate can also affect soil formation. The warmer an area is, the faster generally the breakdown of organic matter is, and that is going to lead to an increased rate of soil formation, as that dead organic matter gets turned into humus at a much faster rate. However, if it is colder, then it's going to really slow down the rate of biological activity, which really slows down the rate of soil formation. All that dead organic material is just going to kind of build up. Precipitation is another factor of climate that can affect the rate of soil formation. When we have really high precipitation, we're going to have high rates of soil formation because we're going to get a lot of weathering, and it's going to break down the rock and contribute more little rock fragments that build up the soil. However, if there's too much wind or too much rain in an area, this can also erode the soil and decrease the rate of soil formation. Rain and wind really can impact soils in different ways depending on the slope and all the other factors. Then we have soil organisms. Decomposers like earthworms, fungi, and bacteria have a really important role to play in soil formation. The higher the activity of the decomposers in an area means the more of them there are. The warmer it is to support the activity, the faster the rate of soil formation, because we're getting breakdown of organic matter that is contributing to more humus and a deeper soil. Soil horizons are sometimes called soil profiles. We are looking at a cross-section here of soil. We will go through the different layers and talk about each of their important characteristics. The first one is the O horizon. This is a shallow layer of primarily organic material that rests on top of the soil. This is going to be mostly things like plants, roots, dead leaves, and animal waste. It is really important because 1, it provides the nutrients that will be essential to nourishing plant growth in the future after they're broken down, but also this layer traps moisture into the soil and prevents water from being evaporated. So organic matter on top of your soil is really important. Then we have the A horizon, sometimes known as the topsoil, and this is a layer largely of humus, which is decomposed organic matter that came from the O horizon layer, and then minerals that come from the parent material below. The A horizon is extremely important because it houses most of the biological activity. This means that most of the breakdown of organic matter will happen in the A horizon, which also means it's going to hold much of the nutrients of a soil. Then we have the B horizon, also known as the subsoil, that's going to sit beneath the A horizon. And it's going to be a little bit lighter in color because there's typically going to be more clay and less humus. Humus, remember, is the black sort of dark component of soil that gives it its characteristic color that we think of when we think of soil. There's going to be little to no organic matter down in the B horizon. It will still contain some nutrients though. Then we get down to the C horizon. This is the least weathered or the most intact rock. It is going to be similar to the parent material, or sometimes what we refer to as the bedrock. Soil degradation is the loss of the ability of soil to support plant growth. This is a really harmful thing that happens to land in 3 different ways. First, the loss of topsoil is often caused by tilling or the turning of the soil for agricultural use. This makes it a little bit easier to plant your seeds, but it's going to disturb the soil and allow it to be eroded by wind and rain easier. The loss of vegetation can make the soil more prone to being eroded because the roots of plants are really important stabilizing structures. The loss of topsoil has a lot of negative effects on the productivity of that soil. It is going to dry out the soil because we're losing that organic layer that was very moisturizing, which means we are losing a lot of the nutrients contained in the topsoil and are still losing a lot of the organisms that are recycling nutrients, which is really kind of a triple whammy when the topsoil is lost. Secondly, compaction is the compression of soil by machines such as tractors or bulldozers, things like grazing livestock such as cattle or sheep, and then even just humans walking an area can cause soil compaction. The problem with soil compaction is it forces the soil particles closer together, which eliminates the pore space, which is really vital for holding water. Think of soil as kind of like a sponge. If you squeeze it or smash it down, it can't hold moisture as well, and that becomes a problem because dry soil erodes more easily, and dry soil supports less plant growth. The third way that soil is degraded is kind of a byproduct of the loss of topsoil, and that is nutrient depletion. When you repeatedly grow crops on the same soil over and over again, each year they remove some of the nutrients that are found there, and as they do that, the soil is going to be less productive or less able to support plants in the future. Our suggested science skill to practice for 4.2 is to identify a research method, design, and/or measure to be used. I want you to practice by trying to design an investigation to measure the effect that climate has on soil formation. You need to identify the independent variable and the dependent variable in this investigation. To do this, you will identify a question to answer, identify the independent and dependent variable, and create 5 to 7 steps to follow as if you are doing the actual experiment. When you finish, please take photos of your notes and upload all pages to Canvas.